Factoring, the greatest common factor, the GCF. When finding the GCF, look for the largest factor in common with every term. That's what you want to do. You want to take that out, factor it out, okay? So GCF is the first thing you learn when you factor. Therefore, you always look for a GCF first. I'm going to talk about identifying problems, how many terms there are, that kind of stuff in all my factoring videos. But the very first thing you always do is look for a GCF. Okay? So let's factor these completely. We have two terms, 6x and 6. What do they have in common? Well, they have a 6 in common. So factor the 6 out. Open your parentheses. This is sort of, GCF is the opposite of distribution and multiplication of polynomials and things. So here, 6, and then what's left over? If I divide a 6 out of this, I'm left with what? Good old x. And then what if I divide a 6 out of this? I'm left with what? 1. So x plus 1. If I have two terms here, I've got to have two terms inside here, okay? Unless I could have simplified beforehand. So 6 and then x plus 1. So again, I have two terms. I can't simplify them, so I'll look for a GCF. What do they have in common? They have a 7. And then in parentheses, I've got to have what's left over here if I take the 7 out. M. Minus, if I take everything out, there's a 1 left, okay? Because you're dividing. 7 divided by 7 is 1. This way, if you distribute, 7 times m is 7m. 7 times negative 1 is negative 7. Okay? So that's what's happening there. It's the opposite of distribution. So here, what does 5y plus 20? What does 5y and 20 have in common? Well, 5, right? And if I take a 5 out, I'm left with y plus how many? 4. Very good. Y plus 4. And the way you know you're done factoring, by the way, you know you're done factoring when there's no GCF that's left in your parentheses. All your pluses and minuses are in parentheses. This plus is in parentheses. That's in parentheses. The only caveat to that, the only exception is if like this was a negative 7. That's okay if it's a leading negative. And the other thing is your power inside here, if it's bigger than 1, you try to factor. None of these are bigger than 1. It won't always factor, but that tells you, hey, I may not be done yet. Okay? So let's look here at some more of these. X squared plus 9x. So here, what do they have in common? They have an x in common, and what's left over? X plus 9. All my pluses and minuses are in parentheses. The power is not bigger than 1. No more GCF. I'm done factoring. That's how I know every time. So then here, what do these two terms have in common? 10m squared and 15. So they have a 5 in common, right? And I'm left with what? 5 times 2 is 10. I didn't bring any m's out, so both the m's are still there, m squared. Plus 3 times 5 is 15, so there's a 3 there. Now here, plus is in parentheses, I have a squared. That means I may not be done, but in this case, this thing here, these two terms won't factor, and we'll learn more about that in other videos as we go through this, okay? If you're in a class, it'll be other sections of your book, but however, you'll learn more about those and why that won't factor later. So I've done very well here and picked problems out that won't do anything but a GCF. So if you look up and go, oh, won't that go further? No, none of these should go further. And if I make a mistake, I'll fix it. You'll never know it. All right. So all these will be that way where they won't go any further. So here, two terms. I have a GCF of 9. And look, x to the 4th and x to the 7th. If every term has the power and I take the lowest power out, like I did the x over there on the green one. So x to the 4th. And if I take a 9x to the 4th out, what's left here? Nothing's left, but you have to write a 1. You have to have something in there for that term. So that's 1 minus 3. And then if I bring out 4 of the 7x's, that leaves me with how many? 3, okay? So 3x to the 3rd. And again, this power is bigger than 1, but this thing won't factor any further, okay? This one won't factor any further. Just a GCF is all there had. All we had there was 9x to the 4th power. So then 12x squared plus 16x minus 8. There's 3 terms here. Do they all 3 have something in common? Well, look, I can take a 4 out of all of them, right? Nothing bigger than a 4. So let's take a 4 out. And if I bring a 4 out, that's going to leave with a 3. I didn't bring any x's out, so x squared plus 4x minus 2. Again, I have a power bigger than 1, although all my pluses and minuses are in parentheses. Okay, so I'm good there, but this one, again, won't go any further. If you tried to do some more with that and you know how to factor that, you'll find out that that won't go any further. Again, I've tried to choose ones that will only have a GCF and nothing else. All right, so here, 3 terms again, 15x to the 4th, 30x to the 3rd, 10x squared. Notice this term in the previous problem didn't have an x, so no x came out. But here, x is in every term. When that's the case, a variable's in every term, you take out the lowest power, x squared. On my numbers, 15, 30, and 10, what do they have in common? Just a 5, right? So if I take a 5x squared out, I'm left with 3x squared, right? Because 3 times 5 is 15, and I took 2 of my 4x's out. That left me with 2. Plus 6 times 5 is 30, and I have 3 x's and took 2 of them out, so there's 1 left. Plus 2 times 5 is 10, and I took both my x's out, so there's no x's here. Again, power is bigger than 1. However, 3x squared plus 6x plus 2 will not factor any further. So that one is finished or done. All right? So let's look at a couple more of these. I'm doing this mainly because if you're in a class, your author of your textbook is going to love some negatives. So if the first term is negative, even if nothing else comes out, I'm going to factor just a negative out. Okay, now here more comes out, but if the first term is negative, unless I'm doing difference of squares when we get to that video, all right, I won't factor a negative out if the leading coefficient is negative, so to speak. All right, so here I'm going to take a negative out, and what else do 12 and 18 have in common? A 6. If I take negative 6 out, that's going to be a positive 2p squared, right? Because a negative times a positive is negative, right? It changes. When you take a negative out, all the signs change. So that means this plus is now going to become a what since I took a negative out? It's going to become minus. How many times will 6 go into 18? 3. Again, the power is bigger than 1, but this one will not go any further. Okay, you'll have to trust me on that right now if you don't know. Okay, that one will not go any further. And then this final one here is 3 terms. Again, this leading thing is negative, so I know I'm going to take a negative out. And then what do 18, 9, and 6 have in common? A 3. A 3. And then does every term have an x? Yep. So I'm going to take an x out, and I'm left with, remember, all the signs change. So this negative becomes a positive, and 3 times 6 is 18. And I had 3 x's here, and I brought 1 out, so it leaves me with 2 x's in here. All right, so it's going to be x, and by 2 x's, I mean x squared. And then the sign changes, minus, right? I took a negative out. That sign's got to change to negative right there. So minus 3 times 3 is 9. I have 2 x's and brought 1 out. There's 1 left over. And then again, I took a minus out, so that plus becomes a what? A minus. Minus 3 times what is 6? 2. I have an x. I brought an x out, so there's no x's left for that 2 over there, that negative 2. And again, if you try to do this and factor it further, it won't. So that is all you can do there for the GCF. But I wanted to show you a couple with negative leading coefficients. All right. So this is greatest common factor. I hope it helps you with factoring. Again, this is the first thing you learn. You always look for a GCF first.